Good morning, everyone. I'll just get it started. Our topic for today is about the protein composition characteristics and the digestibility of different raw materials. As we previously discussed that there are three external forces and three internal forces in designing the suckling piglets feed. The three external forces mainly focus on the selection of the raw material that are first to reduce the intake of the harmful substances, which is nowadays the popular concept clean diet. The second part is to improve the digestibility and utilization of nutrients, especially protein. While the digestibility and utilization of protein improved, it can not only improve the production performance and also prevent the indigestible protein to get into the hindgut, to ferment and then cause the diarrhea. The third part is to reduce the harmful bacteria to get into the animal's intestine, especially the intestinal epithelium, and break the balance of the flora. For the three aspects above, we focus on the second part, protein digestibility today. The digestibility of protein, it is mainly consists of two aspects. One is the structure of the protein, that is the digestibility of the protein. Another is the digestion and absorption capacity of the pig, which is decided by the age and health condition of the animal itself. In terms of the digestibility of the protein, we are all aware that the structure of protein determines its characteristics, which directly affect its digestibility. So today we're going to discuss the characteristic of the protein structure and the actual digestibility in animals. From the picture, we can simply classify the protein as animal protein and plant protein based on its source. Or we can see that picture from the chemical point of view. We also divide them as simple protein and binding protein. Simple protein, that is protein composed of a single protein structure like globulin. And the binding protein, in terms of the structural characteristics, it is not only composed of protein but also performed by the binding with other elements or chemical components, for example, the protein and nucleic acid. These two bind together to form the nucleoprotein. And we can see that we make a summary of the structural characteristics for some proteins. The first one is albumin. The molecular weight is relatively small and is easily soluble in water, in salty, in dilute acid, and dilute alkali solutions, and can be precipitated by the saturated ammonium sulfate. The typical are wheat albumin in wheat, the serum protein in the blood, and egg albumin in the egg white. The common protein that we usually use in animal feed are wheat protein and the blood plasma. The second one is the globulin. Its structure actually is really very close to the name. It is a globular structure. The outside of the globule is a hydrophilic structure and the inside is a hydrophobic structure. So it is difficult to dissolve in water but can be dissolved in the dilute salt, dilute acid, dilute alkali solution, and can also be precipitated by the semi-saturated ammonium sulfate. For plant source protein, especially in soybean protein like glycine and beta-coglycine are globulin structure. And for animal, the myosin in the meat, bone meal, and fish meal are also globulin structure. The third one is histones. Histones are hydrophilic structure and also soluble in water in dilute acid solution. Histones are binding protein that exist in the chromosomes. Therefore, they are widely found in viruses of the animals and plants. That is to say, every living organism with nucleic contains histones. It is rich in arginine and lysine, and everyone knows that these two types of the amino acids is very important in the animal feed. The fourth one is the protein. It can be easily soluble in water and dilute acid, and the molecular weight is very small. Most of the protein is composed of the basic amino acids and lack of the tyrosine and tryptophan. Protein generally exists in the mutual sperm cell and bind to the DNA. The most common one is the protein from the fish, and the contents of the protein is normally very low in the feed ingredients. The fifth one is the prolamine. Prolamine, also known as alcohol-soluble protein. It is soluble in alcohols, but insoluble in water and dilute salt solution. This type of the protein is mostly found in the seed of the gramineous plants. The raw material of the gramineous, such as the corn and wheat, contains a large amount of the prolamine. The most typical one is the gliadin in the corn. The sixth one is gluten. Gluten is insoluble in water and a dilute salt solution, but soluble in the dilute acid and the dilute alkali solution, such as the rice gluten in the rice and broken rice, and the wheat gluten in wheat. So the last one is hard protein. The structure is characterized by the rich disulfide bonds forming a protein cross-link structure. So it is insoluble in water, salt, dilute acid, and dilute alkali solution. Thus, it is not easy to dissolve in mild solution. Hard protein mainly exist in the skin, in hair, fur, and nails, such as the collagen. They are basically undigestible to animals and requires a very certain condition, such as strong acid and strong alkali, to break the protein structure. Its nutritional value is also very low. After we learned that the protein structure of these raw materials, let's take a look at the correlation with the digestibility of different raw materials in animal feed. We know that both protein source and energy source can provide the protein contents, in which that protein source can provide the highest amount of the crude protein. The protein raw material commonly used in the feed including the plant protein, animal protein, and the microbial protein. For the plant protein, the most commonly used in suckling piglets feed is soybean source protein. And in aqua and poultry feed, the selection also goes to the cottonseed meal and rapeseed meal. And for the animal protein, the most widely used in the feed is fish meal. There are also meat bone meal like chicken meal and pork meal, as well as the blood plasma and milk powder. This kind of animal protein source usually used in the high quality animal feed and young animal feed. Microbial protein is a kind of single-cell protein in which yeast protein is the most common one in the feed. Actually, there is a great difference of the structure among these three different types of protein. The plant protein are mainly globulin, as we mentioned that globulin, it is one kind of protein with a globular spatial structure, so it is very tight in the third and fourth level of the protein structure. And in the same time, it contains abundant of beta sheet and irregular curl spatial structure, so that the digestibility and the solubility of this kind of protein itself is very low. And animal protein, it is mainly myofibril protein and saccharomyoplasmic protein. The 3 and 4th level of the spatial structure is relatively scattered, resulting in low density and high solubility. So from the structure itself to speak, it is more digestible. We sorted out the protein structure of these commonly used protein raw materials and find out the corresponding characteristic of different structures. The first type is the soybean meal. Soybean meal is a very common raw material in which the globulin accounts for 70 to 80% and the rest 20 to 30% is the albumin. For example, the protein contents of the soybean meal is 47%, of which the 70 to 80% of them is globulin. That means nearly 30% of the protein in the structure is globulin. And according to the molecular weight, globulin can be divided into 7S globulin and 11S globulin. The 7S globulin, its structure is very tight, with a structure of alpha helix, beta sheet, and the irregular curl accounts for 5%, 35%, and 60% respectively. Among them, which closely related to the digestibility are the structure of beta sheet and the irregular curl. These two structures directly determines the digestibility of the protein raw materials. And also the secondary and the tertiary structure, especially the secondary structure contains the cysteine, which will be oxidized first and then dehydrogenated into the disulfide bonds. And we have a detection method that can detect the free sulfhydryl and the bound sulfhydryl. The number of the sulfhydryl reflects the number of the disulfide bonds. The more the disulfide bonds, the less the digestibility is. The 11S globulin is composed of 12 subunits, and the secondary structure is mainly beta sheet and irregular curl with less alpha helix. It also explains that the reason why the digestibility is relatively lower, since we just mentioned that the beta sheet and the irregular curl structure directly affects the digestibility. And except for the soybean meal, the performance of cottonseed meal is the same as that of the soybean meal. The globulin contents of the cottonseed meal reach up to 90%, and also our detection results confirmed that the relationship of its structure to its digestibility, the digestibility of the cottonseed meal, it is even lower than the soybean meal. So the next part is the common animal protein and the characteristic of its protein structure. The common one is the fish meal, chicken meal, and pork meal. They're all classified as the meat meal, just to come from different animal source. The protein structure of the fish meal mainly includes the myofibrillar protein and saccharoplasmic protein, and the connective tissue protein. We can see that myofibrillar protein contents in fish meal is very high, reaching to 65 to 75%, and the connective tissue protein only accounts for 1 to 3%. And the proportion of the connective tissue protein in chicken meal and pork meal are quite different. In the chicken meal, the connective tissue protein accounts for 5 to 7%, and while the pork meal is 10 to 17%. These proteins are consist of the same structure composition but in different proportion. And what is their relationship with the digestibility? In the following contents, we present some relevant evidence to prove its relevance of the structure to the digestibility. Myofibrillar protein is mainly composed of the myosin and the actin. The two types of the protein can be easily oxidized because they contain sulfhydryl groups, which will form into disulfide bonds and leading to the protein crosslink and reduce the digestibility. The saccharoplasmic protein is mainly consist of the myoglobin and the saccharolysin in the muscle. This part of the protein itself is highly soluble, so its digestibility is also very high. Therefore, no matter what kind of animal protein source is, if the sacroplasmic protein content is very high, then the digestibility will also be very high. In the tissue connective protein, it includes the collagen, elastin. So for example, the tendons contained in the pork and chicken are not easily digested. They're basically some insoluble hard protein and their digestibility is very low. Therefore, the higher the contents of the connective tissue protein is, the lower the digestibility and neutralization is. So the last type of the animal protein is blood plasma. It is recognized as a very good protein raw material because the blood plasma is a raw material obtained by separating bloods, removing blood cell, and spray-drying the remaining plasma. The proteins in the plasma are mainly albumin, globulin, and fibrin. And the solubility and its digestibility of the albumin itself is very good. Therefore, the structure of these three proteins determines that the digestibility of the plasma protein is very high. Besides the protein raw materials, the energy raw materials are also very important. Although the protein contents of the energy raw material is not that high, but the usage in the feed is very high. For example, the protein contents of the corn is 7 to 8.5%, but the dosage of the corn in the feed is 50 to 70% due to the usage in the feed. The protein provided by the corn accounts for about 5% in the whole feed. So we know that in addition of the protein ingredients, we must also pay attention to the protein structure and digestibility of the energy ingredients. The most commonly used energy raw material in the feed, such as corn and wheat, source the flour and starch. And some broken rices and rice also used in the feed for the suckling piglets feed. This type of the protein in the energy raw material mainly includes the gliadin, gluten, globulin, and albumin. In fact, every raw material contains this protein structure, and the digestibility mainly depends on the proportion of this protein structure. The different proportion means different digestibility. As we mentioned that there are two aspects influencing the digestion. One is the digestibility of the raw material, and the second is the digestion capacity of the animal itself. The digestibility of the raw material is mainly decided by the 5 aspects mainly. The first one is the fineness. The higher the fineness means the higher contact area, the possibility of the digestion will be higher. Thus, the fineness of the raw material will affect its digestibility. The second one is the degree of the protein exposure. That means the structure, especially the spatial structure. From the photo below, we can see that from the primary structure, the amino acids, to the secondary structure, the alpha helix, beta sheet, as well as the irregular curl, to the protein subunit of the tertiary spatial structure. The quaternary structure consists of the protein subunit connecting by the covalent bond as a complex spatial structure. Protein exists in the natural with its stable spatial structure. We need to open the quaternary and the tertiary structure to expose the protein. In this process, the key is to open the covalent bond, like the disulfide bond. We need to decrease the quantity of the disulfide bond to expose the protein for the enzymes to digestion. So the third part is the solubility of the protein. In the spatial structure of the protein, the outer side is hydrophilic amino acids, and the inner is the hydrophobic amino acids. When a spatial structure is opened, the hydrophobic amino acids will be exposed and precipitated in the water. Thus, we need to improve the solubility of the protein as much as possible. So the fourth one, The first one is the complexity or the tightness of the protein spatial structure. As we've just mentioned that when the spatial structure of a protein is opened, the quaternary structure will be decreased to a tertiary structure. Then the secondary structure, which is more loose and highly digestible. And last, from the secondary to the primary structure, this is very important. It is a process of degrade the chain of amino acids to contact and react with enzymes and degrade into free amino acids or the small peptides. So the fifth one is the protein molecular weight. The protein molecular weight will just directly affect the digestibility. So all the five factors above are for the purpose of one, that is to degrade the protein into smaller molecular substances to improve the digestibility of the protein raw materials. So how should we evaluate the possibility? Which method is better? Currently, we know that there are in vivo and in vitro methods. So the in vivo method is a comparison of nutrients in the diet and a chyme in the end of the ileum to evaluate the digestibility of the animal body. It is more realistic. However, this method is really limited to be used only in the institute universities, not only widely used due to its time-consuming and high cost and its complexity. Besides, this method is very realistic. But in addition to this method, is there any faster and a simple method? The answer is yes. It is a vitro method. There are two vitro methods could be used. One is a bionic digestion method and another is double enzyme method. Bionic digestion method is to stimulate the digestion in the stomach of the intestine. For example, the inspection of protein will stimulate the digestion in the stomach and the small intestine with similar environments, activity of enzymes, pH value, and the time of the enzymolysis. Then detect the digestibility and each timeline. The inspection of the energy raw material should stimulate the stomach, small intestine, and the large intestine, which secrete the enzymes to degrade the fiber and supply energy. This method is high cost and complicated as well. Thus, we have to develop some lab method that is faster and simple to operate. In the recent years, the double enzyme method is very popular. It is processed with two enzymes to react in a corresponding time and pH value. This method is already well developed and widely used, but not so much realistic since the digesting capacity of the animal is not in the consideration. For example, when there's an injury in the intestine, the digesting capacity will be decreased. So this injury of the intestine thing we cannot stimulate. But we can use the in vitro method to have a relative result when comparing the digestibility of different kinds of raw materials. When designing the formula, we need more realistic data for the calculation. The references data from the NRC or the China Feed Ingredients database are mainly for the piglets. The piglets of the body weight that is around 30 to 50 kilogram. Well, the digestibility on the younger animals is quite different than that. Thus, the data is not very suitable. And we sourced from many papers of the digestibility for some common protein raw materials in the body of the animals and make a summary of the digestibility of the three key stages, that is the digestibility of the body weight that at 6 kg, 10 kg, and 25 kg to match the commonly used growth stage in the formulation. Below are the details that we summarized. Here you can see that the CP level, apparent yield digestibility, and the 6 kilogram, 10 kilogram of the body weight for the fish meal, dry protein soluble, milk powder, dilute soybean meal, fermented soybean meal, soy protein concentrate, and the hydrolyzed soybean protein, as well as the energy raw material with a certain protein contents like corn, rice, and wheat flour are all listed here. As we know that the CP level is the first parameter for the protein raw materials, but higher value of the CP, that is the crude protein contents, does not mean higher protein utility. The digestibility should be considered. In this chart, the two parameters should be paid highly attention. One is the apparent digestibility in the ileum for the pig and the body weight of 6 kg and 10 kg. The digestion capacity of the animals increased with this growth. Thus, the digestibility of the raw material will increase. In this chart, you can see the digestibility of the same raw material and different growth stage is different. It is higher when it is in the body weight of the 10 kg. And the digestibility of the different raw material and the same stage are different. Since the digestibility is affected by the digestibility of the raw material and the digestion capacity of the animal, so in the same stage, the digestibility difference is resulted from the structure of the raw material. The digestibility of the animal protein source is high on the younger animal, from the 75 to 80%, while the digestibility of the plant protein is relatively low. The common soybean material kind like dilute soybean meal, extruded soybean meal, and fermented soybean meal, soy protein concentrate. The digestibility is within 66 to 74%. Regarding the energy raw material, the crude protein level is not that high, but the dosage in the formula is very high. Thus, the total protein supply to the formula cannot be ignored. The digestibility should be considered as well. For example, the digestibility of corn is 55% on the 6 kg of the body weight piglets, while its dosage in the formula is very high. In the formula of creep feed, we have to control the use of the corn and increase the use of the rice and the wheat flour. For the formula and 10 kg body weight piglet, since its digesting capacity increased, the digestibility of the protein increased accordingly. However, we still found that there are some differences. The digestibility of the animal protein have a limited increase around 3%. The digestibility of plant protein increased more. For example, the soybean protein kind increased 4 to 5%. However, the digestibility of the protein from the energy source increased about 5 to 10%. Besides, the negative effect of some harmful substances contained in the raw material should also be considered as well. For example, the anti-nutritional factors contained in the soybean meal. It will damage the intestine and decrease the digesting capacity of the animal. The digestibility of the extruded soybean meal is lower than the dilute soybean meal. The reason should also be that the high pressure and high temperature process during its production. It will break the structure of the protein and stick them together, thus decrease the digestibility. The digestibility of the fermented soybean meal increased when compared with soybean meal. The enzyme produced from the microbe during the fermentation will degrade some of the protein into small peptides, which increase the digestibility of the protein. The production of soy protein concentrate. The production of soy protein concentrate eliminates the carbohydrate and decreases its web of protein, thus increase the digestibility of protein. We know that the digestibility of the fresh soil protein concentrate is rather high, while the digestibility will decreasing with the increase of the shelf life. This is a result found by one of the university in China who obtained abundance of the experiences on the food protein. Their study shows that the protein digestibility of soil protein concentrate decreased to 30 to 50% after stored for 3 months. The reason behind is that the expose of the protein after carbohydrate elimination and stuck together and a Maillard reaction happens, which decrease the solubility and the digestibility of protein. We have the similar feedback from some customers on the use of the SPC as well. With this storage, the feed intake is not enough and the diarrhea will increase. The decreasing of the digestibility increase the indigestion burden of the animals, thus reduce the feed intake. Meanwhile, the undigested protein will get into the hindgut, broken the microbiome balance and increase the diarrhea risk. The hydrolysis soybean meal used the enzymes to degrade the protein into small peptides and free amino acids. This process increased the digestibility of the protein. In a word, we suggest a combination or pre-process of these protein raw materials to improve the digestibility and the utility. In production, the most typical in piglet feed, on the condition of very well control of the production process, should improve the digestibility of the protein raw materials.